Hello, we are going to start Unit 6, which is going to be about functions. And so today we're going to focus on some new notation that we are going to be using quite a bit from here on out. So notation is just how we write things. So we're going to learn new ways to write functions. You might have seen it before, but we're just going to make sure that we're familiar with it. I do see this content show up usually on every ACT. There is a question about functions, so it's good to know for your ACT that will be coming up. So first off, let's just go over what a function is again. So a function is where each element of a domain is paired with exactly one element of the range. So remember, domains, these are like your x's, and your range, this is like your y's. So we're thinking kind of like horizontally and vertically. So a function doesn't necessarily have to be a graph. They can give it to you. You might remember seeing these like mapping diagrams in middle school. You probably learned about them, where your domain is given in like one column and they use little arrows to map it to which y value it goes to. So what this is saying, in order to be a function, is each x value or each domain value can go to only one range value. So I can't have more than one arrow coming out. So like on -2, it's going to -3, but if I had another arrow coming from -2 going to 6, then that would be a problem, and we would say it's not a function. So since this one just goes to one number, 0 only goes to one number, 3 only goes to one number, and 4 only goes to one number, then we would say yes, this one is a function. And notice that 0 and 3 both go to number 6. It's okay that they share a range value. It would just not be okay if 3 goes to another number. So we can only have one arrow going out at a time. Sometimes they will be given to you in a table format, like this one right here. So our domain would be this row, and here's our range. So we just need to make sure that each of our domain only goes to one y value. So here we see that 1 is going to 4, but then notice that 1 is being repeated over here. They're saying 1 also goes to -4. That's where we have an issue right here, is that we have that number 1 being repeated. And so it's going to two different y values. So it can only go exactly to 1 in order to be a function. So this one would be no. So check and see, is your x number being repeated at all, going to a different y value? And that's where we have a problem, and it's not a function. And then again, it can always be given as a graph. So you might remember from middle school doing the vertical line test to see if it is a function. The reason we do a vertical line test is because if you're drawing a line vertically and it just goes through the graph one time, so see how these are each just hitting once, my little lines going through, that means each x value is only going to one y value. So yes, this would be a function. This one would not be a function because here I'm hitting 2 times. So this x value right here has a y value up at the top and a y value down at the bottom. It's going to 2 different y's, which is a problem. So no, this is not a function. And then this would be okay. You might have seen these like step diagrams. Notice that we have this line with a closed circle at the end, and then this one with an open circle. Maybe I'll zoom in a little bit so you can see that a little better. So that open circle means it's not including this point right here. So like if I drew a line to do my vertical line test, it wouldn't necessarily be included. I'm not actually hitting my line right there. So I'm only hitting one place. So this one would be a yes. However, if this circle was filled in, so it was black and this circle was filled in, then we would have a problem, and it would not be a function. So let's just look at a couple more examples really quick. Determine whether these are functions and explain. So first we have that little mapping diagram again. So we want to check and make sure each domain is going to just one range. So -4 is only going to -1, -2 is only going to 4, 0 is only going to one number, 2 is only going to one number, 4 is only going to one number. So yes, this one's a function. Okay, sometimes we'll be given as ordered pairs. I haven't seen one like this before. Remember, as an ordered pair, these are like your x, comma, y. So our x values are the first numbers. So we want to check and see, are any of our x's being repeated? Here I have a number 2 going to a y, but look, I also have a number 2 here. So this x value is going to a different y value. This one's going to 2, but this one's going to -4. So this is where we have a problem. So this can't be a function because this x value of 2 is going to 2 different y values. It's going to both 2 and -4. And then here we have some points plotted for us. So far, like if I draw a line through here, I'm good, through here, I'm good. But then as soon as I hit the axis right here, it's kind of hard to see my line over it. Because both of these are filled in, we have a problem. We're saying we're hitting 2 different points. So this x value of 0 is hitting the y value of 1 and a y value of 2, 3, 4, 5, 6. So this one would be a no as well, since at 0 we're hitting both 1 and 6, which is a problem. Okay, so again, I see stuff like this on the ACT. Usually, at least every ACT, I think there's one question about, is something a function or not? So a vertical line test is an easy way to remember, but just remember a function is one domain element is going to exactly one range element. So now we're going to look kind of at the new notation. Equations that are functions, remember a function is one x value goes to one y value, can be written in a form called function notation. So usually up until this point, we've just used y's and x's. But function notation uses this little guy right here. We pronounce this as f of x. So I have that written for you here. So the reason we have this is because we're saying our variable is x, and I can kind of think of this as being something I can plug numbers into. So we're kind of saying if this is my function of x, I can take a number and plug it in and see what I get out of it. So this is not multiplication. Sometimes I have students who see this f and x and they think, oh, I'm timesing f times x. It's just notation. It's not going to be multiplication. It's just how we write that this function is using x as its variable. So it's literally, you're just replacing the y with an f of x. So if they ask you to rewrite using function notation, you're just going to change that y to be an f of x equals 3x plus 4, and that's all you do. So you're really not too crazy. Again, and it will match what your variable is. So in all of these, we're just using x's, but let's say this was like a w, then you would do f of w. So we're just going to change this to be f of x, and then we'll just keep the rest. So we'll have the 4x minus 7. I think you guys probably get the idea. Change this to f of x. Sometimes they might not be solved for y, so all of these had just y equals, but on this one, y is not by itself, so we wouldn't want to plug f of x in with the 4 on it. I mean, you could, it would look kind of weird though. So you would want to start by solving for y, so that we get 4y equals 12 minus 3x, and then let's divide by 4, so that you get that y alone. And then once that y is alone, then you would change it to f of x. So that would be, oh, sorry, you can't even see me. Get y alone first, and then change it to f of x. I mean, you could still plug it in there, but it would just look kind of funny. Okay. So when we have function notation, another thing you might see is stuff like this. So we don't just have to use f. Sometimes we'll use other letters. Usually G is more common to use F, G, and I see H a lot as well. So here we have like a function f of x equals negative x squared plus 7. And then since we have a second function, they just change the letter. So every time we have multiple functions, they'll use multiple letters to kind of denote those different functions. A lot of times you'll be asked to like add or subtract them, which you guys already know how to do. But we just, again, are learning kind of the notation of how you might see it written. So one way is they'll just say, take g of x and add to it f of x, which would mean take my g of x function. So g of x here would be 2x squared minus 4. And I'm going to add to it my f function, which is a negative x squared plus 7. And you don't really need the parentheses. I'm just kind of doing that to show you this is g and this whole group is f. And then you would just add them like you have your whole life. So we would find our like terms. So you have 2x squared can be combined with a negative x squared. So 2x squared subtract x squared would be 1x squared. And then negative 4 plus 7 would be a positive 3. And so that would be your answer. So really the only thing that's new is just how you write these. And the second way to write it is this. So you have the way where it's just the function plus a function, but then sometimes they put it in one set of parentheses. So notice we have f minus g of x is how you would read that. This f minus g is just telling you to do your f function and subtract your g function. It's just a different way of writing it. So same kind of idea, but you'll see it this way as well. Again, this is not telling you to times by x. That's just saying that's the variable we're using. We're using x's in our functions. So they're just saying take f and subtract g. So you're not timesing by x or anything. So I take my f function, the negative x squared plus 7, and then we're subtracting the g function, 2x squared minus 4. And then since we are subtracting this whole thing, I'm going to put it in parentheses. Because whenever we're subtracting a whole group, we need to remember to distribute that negative through. So that I have negative 2x squared, and then this subtract a negative turns to a plus 4. So really I have negative x squared plus 7 minus 2x squared plus 4. So let's find our like terms. We have a negative x squared and a negative 2x squared, so that gives us a negative 3x squared. And then 7 plus 4 is 11. That would be your answer. Okay, another thing that you will see with function notation is you will be asked to evaluate. So evaluating a function, this means that you're going to be replacing the x's with whatever value they give you, whatever number. So let's say I have f of x equals 6x plus 7 here, and then g of x equals x squared minus 4. You're going to see stuff like this with the negative 3. Remember, it's usually f of x. Now they're saying, what's f of negative 3? This is telling you to plug in negative 3. So I'm going to do f of negative 3. That means to take negative 3 and replace it for the x inside my f function. So we had 6x plus 7. So instead of x, I'm going to do 6 times negative 3 plus 7. And then you just simplify. So 6 times negative 3 is a negative 18. And then we're adding 7 to it. Negative 18 plus 7 equals negative 11. And that would be your answer. Let's try that again. This time they're saying to do g of 4. So again, that means to plug in 4 for x. So if I do g of 4, here's my g equation, x squared minus 4. Instead of x, I'm going to do 4. So I'm doing 4 squared minus 4. Well, 4 squared is 16. 16 subtract 4 is 12. So whenever you're asked to evaluate, I want you to think evaluate means plug in. So you're just going to be plugging in whatever number they give you. And sometimes you might have more than one x in your equation. Both of these just only had one x, but maybe you have a quadratic that has an x squared and an x. You might have to plug it in more than one time. Okay, and then one last thing for today. So sometimes they might ask you to divide and do like f of x divided by g of x, a function divided by a function. So you would necessarily just, can't talk today, f of x divided by g of x, that just means to do division, which you guys know how to do as well. But remember, one of the main rules in math is that you can't divide by 0. So when you divide, you can't have 0 in the denominator because that's undefined. We're not allowed to do that in math. So sometimes they'll say, well, what's the domain? Remember, domain means what x values can you use. So if they're saying what is your domain that you can use, that's what x's can you use. So let me zoom out a little bit. I keep cutting my screen off. So you're trying to decide what the domain is or what x's that you can use, and you need to exclude or throw out any values that make you have 0 in your denominator. So you do need to watch for this whenever you have a fraction or whenever you're dividing functions. So let's say here was our f function is 4x and g is x minus 5. So we have 4x over x minus 5. Remember, I can't divide by 0. So I need to think, when would this function equal 0? So to get your domain, we're going to set the denominator equal to 0 and solve. So I'm going to take this x minus 5 and set it equal to 0. I want to know, when does this equal 0, because I can't have that. So if I start solving for x, I would need to add 5 over. So those cancel and I get x equals 5, which makes sense, right? Because if I plug 5 in, I would get 5 subtract 5, which is 0. I can't have that. I can't have 0 in the denominator. So instead of saying x equals 5, we're going to say x can't equal 5. We're going to put that little line through it. So our domain is, we're saying x can be any number except for 5. So there's a couple ways to write it. So for your domain, you could write it this way. You could say x can't equal 5, which implies that it is okay to be anything else. Another way you could write it is, you could say I'm coming from negative infinity up to 5, but I can't use 5, so I'm going to put a parenthesis on it. So remember, parentheses mean we're not using it. And then I'm going to put a union symbol, and then I can say, okay, but then I can go from 5 to infinity. That's okay. So that's another way to do it. Usually though, if there's just one number excluded, you could probably just write it like that. Next year in secondary 3, you'll use a lot more of this interval notation when writing your answers. So that is kind of your first look at function notation. Again, it's just a way to write things. You're not necessarily doing anything new that you've never done before. Like, you guys know how to plug numbers in, you know how to add and subtract. It's just kind of seeing, what does this f of x mean? What does f minus g of x mean? So hopefully that makes sense. It's just again a way we write different things in math. Hopefully you'll get more familiar with it as we go on. It will just kind of become second nature to you. But if you have any questions or get stuck, again, feel free to reach out to me. I'm here to help. Hope you guys are safe and healthy, and I will talk to you later.